Have you ever stood on a beach and watched waves endlessly roll toward the shore? No matter where you are in the world, the ocean seems to be in constant motion. Some waves are small and gentle, while others grow into towering walls of water that surfers dream about. But have you ever wondered how these waves actually form? What causes the sea to rise and fall in such a rhythmic way? Surprisingly, the answer begins not in the water itself, but in the air above it. Today, we're exploring how waves form, right here, on History of Simple Things. At first glance, waves might seem like moving water traveling across the ocean. But what's actually moving is mostly energy. The water itself moves in small circular patterns, while the energy travels forward, creating the familiar rise and fall we see. Even on calm days, the ocean is rarely perfectly flat. Tiny ripples are constantly forming on the surface. Those ripples are often the starting point for larger waves, and the process that creates them begins with one of the most common things around us: wind. Most ocean waves are generated by wind blowing across the surface of the water. As air moves, friction between the wind and the water transfers energy into the sea. At first, only tiny ripples appear. These ripples create rough spots that give the wind something to push against more effectively. As more energy is transferred, the ripples grow larger and larger. Eventually, they develop into waves. This process happens constantly across the world's oceans, which is why waves are always present to some degree. The stronger the wind, the more energy it delivers. A gentle breeze may create small waves, while powerful storms can generate enormous swells that travel thousands of kilometers across the ocean. Not all waves are the same. Their size mainly depends on three factors. The first is wind speed. Faster winds transfer more energy into the water, producing larger waves. The second is how long the wind blows. If strong winds continue for several hours or even days, waves have more time to grow. The third factor is something called fetch. Fetch refers to the distance over which the wind blows without interruption. Over a large stretch of open ocean, the wind has plenty of room to build increasingly bigger waves. When all three factors come together, strong winds, long duration, and a large fetch, massive waves can develop. One fascinating thing about waves is that they can travel incredibly far. A storm in one part of the ocean may generate waves that reach coastlines thousands of kilometers away. These long-traveling waves are called swells. Unlike the choppy waves near a storm, swells are smoother and more organized. Surfers often wait for these swells because they create ideal conditions for riding waves. What's remarkable is that the energy from a distant storm can continue moving across the ocean long after the weather itself has disappeared. It might seem as though water is racing toward the shore with every wave, but that's not entirely true. Imagine floating on a raft in the ocean. As a wave passes underneath, you rise and fall, moving in a roughly circular motion. But you don't travel all the way to the beach. The water molecules behave similarly. The wave transports energy, not large amounts of water. This is why objects floating in the sea tend to bob up and down rather than continually drift forward with each passing wave. Out in deep water, waves can travel smoothly for long distances. But as they approach land, things begin to change. The bottom of the wave starts interacting with the sea floor. Friction slows the lower part of the wave, while the upper part continues moving faster. This causes the wave to become steeper and taller. Eventually, the crest becomes unstable and collapses forward, creating the breaking waves we see crashing onto beaches. That dramatic splash is actually the wave releasing much of its stored energy. The shape of the shoreline and the slope of the seafloor also influence how waves break. Some beaches produce gentle rolling waves, while others create powerful surf. Although wind is responsible for most waves, it isn't the only cause. Earthquakes beneath the ocean can suddenly displace enormous amounts of water. This creates tsunami waves. Unlike ordinary waves, tsunamis involve movement throughout the entire water column and can travel across entire oceans at speeds similar to jet aircraft. The gravitational pull of the moon and the sun also affects the oceans, producing tides. While tides aren't usually considered waves in the everyday sense, they are a type of wave with extremely long wavelengths. Volcanic eruptions, underwater landslides, and even meteor impacts can generate waves under certain conditions. Here's an interesting fact. You don't need an ocean to see waves. Lakes, reservoirs, and even ponds can develop them. Whenever wind blows across a body of water, energy transfers from the air to the surface. The same basic principles apply whether the water covers a few hectares or an entire ocean. However, smaller bodies of water have shorter fetch distances, so their waves are usually smaller and less powerful than ocean waves. Some of the most powerful waves are created during major storms. In the Southern Ocean, where strong winds blow almost continuously around Antarctica, waves can reach extraordinary heights. Surfers also seek out giant waves formed by special underwater landscapes. Places like Nazaré in Portugal are famous because submarine canyons beneath the ocean help focus wave energy, creating waves that can tower over buildings. Meanwhile, rogue waves occasionally appear far out at sea. These unusually large waves can form when multiple waves combine, producing a wave much bigger than those around it. Though once considered myths, they are now known to be very real. The next time you visit the beach and watch waves rolling toward the shore, you'll know that you're witnessing energy that may have started hundreds or even thousands of kilometers away. Most waves begin with nothing more than wind brushing across the water, gradually transferring energy that grows into the powerful motions we recognize so easily. From tiny ripples to giant swells and even tsunamis, waves are reminders that the Earth is constantly in motion. They connect the atmosphere, the oceans, and the forces of nature in ways that are both simple and extraordinary. And despite seeing them almost every day, waves remain one of nature's most beautiful demonstrations of energy and action. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.